So let's zoom in a little bit more. Why are you talking still? Okay. If you need Quizlet, you may turn it on. Let's talk about vocabulary. The constant K. We've talked about this guy before, right? In fact, it's one of the cards. It is the constant of proportionality. Very good.
Very good.
I can't write in that space. It is the constant of proportionality. And we already know, and we're going to get down here where y equals kx, where k is non-zero. That is the equation that's up there. So k is the constant of proportionality. We also know it by other names. We know it by m, or slope, or rise over run, or y over x. We know all these things, right?
I fit it in a line.
Good job. So, let me use this. So, a linear relationship between two variables, x and y, that can be written in the form y equals kx. What do we call that? It's called direct variation. Very good. Direct variation means that it starts at the origin. Some Wookiees die in the process of making that equation. Yeah, I never thought about that, but thanks. Shh. All right. What are ratios that name the same comparison? What do we call them? Equivalent ratios. And things I'm talking about, why are there conversations? When we talk about equivalent ratios, think about things like this. Think about equivalent ratio. 1/2 equals 4/8. They're really the same ratio, aren't they?
Yeah.
Because 4/8 is just 1/2. It is an equivalent ratio. If I said 1/3, what's an equivalent ratio for 1/3?
2/6.
2/6. Very good, Timothy. Yes, sir?
Oh, my computer's not turned on.
Okay. Just hold the power button and
Fix the problem.
solve the problem.
So,
Okay, I don't have time. Just wait. You're going to have to wait. All right.
I know what you're going to say before you leave.
So, an equation of solutions form a straight line on a coordinate plane. It's a linear equation. It's what this whole unit's named. It's a linear equation because it makes a line. Linear equations make a line. We're going to talk about two. We're going to start with proportional relationships, and then we're going to move to non-proportional. Rice. You okay?
Yeah.
Okay.
I thought you said rise.
No.
I like rice.
right.
All right. A pair of numbers that can be used to locate a point on a coordinate plane. It's called an ordered pair. An ordered pair. Keep your conversation to this. When you think about an ordered pair, we always write them as x, comma, y, which might be the same as 1, comma, 2. That's an ordered pair, where I give you the x and I give you the y. It's called an ordered pair of coordinates. We have the y coordinate and the x coordinate. Together they make an ordered pair. They are a point on that line in that linear equation. Let me move this to the top. All right, an equation that states that two ratios are equivalent.
Proportion.
It's a proportion.
An abortion. Not an abortion.
Mr. Wheeler, you're talking about your things that I do not understand.
All right, those of you who keep saying that over and over again, it doesn't make it funnier every time you say it. No, I wasn't talking to you, ma'am.
Okay. Talking to Omar.
I was talking to the people who kept saying what they didn't need to say. So, shh. A proportion says that two ratios are equivalent. I put 1/10 equals x over 20. I've written a proportion. I haven't solved it yet, have I?
No.
But I've written a proportion. We did this yesterday, didn't we? And we know we can do that little cross X there like X-Men. Be like Wolverine. Put it all together.
Cyclops.
All right. Number 7. A relationship between two quantities in which the ratio of one quantity to the other quantity is constant.
Proportional relationship.
Proportional relationship.
They're on wood. And I
They're
can't
using
see
their resources.
Exactly. Thanks, Omar. They literally don't have the computer. My computer's probably.
Now, when you guys get home tonight, you can tell your parents we talked about relationships today in school, and just end the conversation right there because it sounds better. Instead, a proportional relationship is just that. I ran you off on a tangent, my fault.
It's okay.
A proportional relationship is where we say there's a relationship and it creates a line. A proportional relationship always goes through the origin. It goes through 0, 0. 0, 0 is one of the points in a proportional relationship. It must be one of the points in a proportional relationship. Number 8. A ratio that compares two quantities measured in different units.
Rate.
It's a rate. Think about this. A rate is things like Kirsten. Things like miles per gallon. I'm comparing miles and I'm comparing gallons. Haley.
I'm sorry, I'm holding my foot out.
Okay, but you're not right now. Miles per gallon. Things like inches per foot. That is a rate. I'm comparing two dissimilar items together. Calories per ounce or calories per burger. That would be a good ratio. A rate. All right. A ratio that compares the amount of change in a dependent variable to the amount of change in an independent variable. Rate of change. All right, I wrote below that the equation y equals kx. X is an independent variable. So x is your independent variable. And y is your dependent variable. And I want you to think about this. Y only gets what comes out of the equation. Because we put x into the equation. X is independent means it can be anything it wants. But y will depend on whatever x is to be what it is. So if I have an equation like y equals 2x, pretty simple, right? And I tell you that x is 2. Well, what's 2 times 2? 4. So y is 4. Does that make sense? But the y didn't find out what it was until x decided what it was. X is independent, whereas y is dependent. Okay?
Things like their social life.
We're not talking about that.
Yes.
All right. Number 10. A measure of the steepness of a line on a graph. It is slope. We're going to go over slope a lot. Whoops. I want you to think about this, and this is the dance move you have to know. Pay attention.
I know it.
Positive slope. Put your right hand in the air. If it rises to the right, it's positive slope. If it rises to the left, it's negative slope. Now, here's the deal. We talk about steepness of slope. A slope that's 0 is the world's most boring line. Sit down.
Be humble.
0 is a boring line if you're on a skateboard. It means you gotta. Now a slope that's like 1/2, it's pretty small. But when we get up here where the slope is 100, 150, that line is getting pretty steep, right?
Like a roller coaster.
Yeah, that's why I scream and my mother won't ride with me anymore.
I've never
Okay.
been on a roller coaster.
Is that why she doesn't listen to you?
What?
Oh! I get there.
What?
Oh!
There's a snake.
There's a snake in my
So. Alright. Let's talk about a linear equation written in the form y equals mx plus b, where m represents the slope and b represents the y.
Slope intersecting form.
Slope-intercept form. It has another thing it's also called commonly. A lot of time it's called the Y-intercept.
Will you stop? They're not my mom.
A lot of times it's called the Y-intercept form because the Y-intercept, and that is, when I say intercept, think about a car driving down a road. Intercept is when it hits the wall that we erected in the road. The Y-intercept is when the line hits the Y-axis. That's the axis going straight up and down. So wherever the line's going, whether it's going up to the right or up to the left, as soon as it hits that Y line, we call that the Y-intercept, that point. Does that make sense? So Y-intercept becomes the most important thing there. All right, a set of equations that have the same variables.
System of equations.
System of equations.
Whoa. It's just thank you. Whose birthday is it today?
System of equations. So a system of equations helps us decide how much we can do of each thing. And we're going to get to that. It's like you go on vacation. And you go to this expensive theme park. Although most of them now don't do that. Or let's go to the carnival.
Never been done.
So the carnival has food and it has rides. You've got to find that point where you get all the rides you want and all the food you want and figure out to match up the money you have. Does that make sense?
Yes.
That's a solution for a system, well, of equations. Okay, let's go to the last one. The last one. A rate in which the second quantity is a comparison to the one unit. So, let's go back to before I was talking about the rate, like miles to gallons. If I went 300 miles and I used 5 gallons. So, if I said this car is rated for 300 miles for 5 gallons, that kind of sounds dumb, doesn't it?
Yeah.
Why? Because I'm asking you, the consumer, to do math. So if I divide 300 by 5, what do I get? What's 300 divided by 5? 60. This car goes 60 miles per gallon. The gallon is a 1. The one on the bottom is always 1. So it's very fast for you to figure out what's going on. 60 miles for 1 gallon of gas. Does that make sense? So a unit rate converts that bottom number to a 1. No matter what it is, it becomes a 1. Does that make sense? What does this class go to? 150. All right. Any question? Open up, get on Quizlet.
My computer is the fun one or the baby still recording? Hi, Mom.
One day.
Hi, Nene.
He said he'll tell her.
I love you.
I know.
Come on, take it away.
This isn't even yours. No, it's not. No, it's not. All right, get on Quizlet quickly. Log on. Log on and get on Quizlet.
So it's not Quizlet Live?
Omar, you're 28. Catherine's 27. All right. Is everyone on Quizlet?
No.